Hey, welcome back to the review for Unit 6. And in this section, we're asked to match each graph to the function that created it. And we'll start with graph A. It's an increasing function, and it's got asymptotes at pi over 2 plus or minus k times pi. The zeros are at the origin and at pi, so every pi units we have a 0. Those are the features of the tangent parent graph. So graph A is tangent. Cotangent is the reciprocal of tangent, and its graph is going to be decreasing wiggles. So same general shape as the tangent, only they're going to be decreasing from left to right. The asymptotes for the cotangent graph are plus or minus k times pi, and the zeros are at pi over 2 plus or minus k times pi. So our cotangent graph is f. Okay, then when we look at 10, that's the sine function. The sine parent graph has a y-intercept at 0, 0, and it makes a continuous wave. It's got its maximum before its absolute minimum, and that would be our graph C, right? We have our y-intercept at 0, then a continuous wave with the maximum before the minimum. The zeros are at plus or minus k times pi, so C is our parent graph for sine. The cosine is the same shape as the sine graph, only pi over 2 units, and that would be our graph H. It has its y-intercept at 0, 1, and it makes that cozy hammock shape that we talked about. So H would be the parent graph for cosine. The reciprocal of the cosine is the secant, and each of these absolute extrema become relative extrema for the parent graph of secant. And then the zeros of cosine are the asymptotes. So when we compare that to graph B, we see that our secant graph is going to have to be B. Okay, then similarly, the reciprocal of the sine function is going to have its alternating U-shapes connecting at the extrema. There we go. And each of our zeros for sine become asymptotes for its reciprocal. And the reciprocal of sine is the cosecant. So that would be graph G is the cosecant. Secant and cosecant have the same shape. They're alternating U-shapes. They're just pi over 2 units apart from each other. Then our last two graphs we want to match are the inverse graphs for sine and tangent. The inverse of sine is the arcsine, and arcsine is only defined between negative pi over 2 and pi over 2. That's the region of the graph of the inverse that passes the vertical line test. So the actual inverse graph would continue, right, forever up and down with this wave, but we chop it here at negative pi over 2 and positive pi over 2 so that it passes the vertical line test. And that's where our principal values are found in the calculator, since that's where the inverse is a function. So graph E is the arcsine. Then the arctangent is going to be graph D, and we only have one of those sideways wiggles in our arc tangent, again, so that it would pass the vertical line test. It's defined between negative pi over 2 and pi over 2 in the y direction. And our principal values in the calculator will come from that region of the inverse graph.